Hello and welcome to day 7. So today what we're doing is ranking poker hands, or almost. So our input is going to be a list of poker hand and a bid. And what we need to do is go through here and sort their poker hands and then multiply their position by their bid. So like this is the worst hand, just a single pair. And so we're gonna have 1 point times the 765 bid. This is our best hand, queen, queen, queen. So out of 5 hands, the N number will always be the best. So 5 times 483 is our score for that. We're going to go through after we sort them up, just count them, sum them together, we're done. A couple of differences between that and regular poker though. The rankings are 5 of a kind, 4 of a kind, full house. There are no flushes or straights. There aren't any suits either, so makes it slightly easier. And then after that, 3 of a kind, 2 pair, 1 pair, high card. And then the tiebreaker is a little bit different. So like in regular poker, obviously your tiebreaker is usually going to be, high pair, high triplet, high card, whatever the distinguishing value is. And here we actually care about the hand order. So for example, this one we have 2 pairs, 2 kings, 2 sevens. This one we have 2 pairs, 2 jacks, 2 tens. So the tiebreaker is going to be not king, king, right? That's the best pair. Instead it'll be this king versus this king. They're the same. So we go on to the second card, and this king versus this 10. Well, this king is better, so this one gets the victory. So there can be times where you actually have a worse hand in regular poker, but a better hand here based off the tiebreaker. So the first thing that I did was I created a list of ordinals here, which is basically our characters to the tiebreaker numbers. So ace is best, king is second, queen is third, so on. And then I had to make a scoring function, and the scoring function, I start with 0. And then for each character in your card or in your hand, I'm going to shift your current score by 4, multiply by 16, same thing, and then add the mapping from whatever your card is. So what this is going to do is it's going to basically be like your first card, whatever your first card is. Let's say it's a king, which is 12, so that's 8 plus 4, right? And then I guess I got that wrong. 8 plus 4. And then we're going to shift that left 4. So then we'll have like 4 more, and then we'll add the next one. The next one's a 2, so I'll add a 1 or whatever. And then once I'm done with all of this, I'll have a 5 pairs number. So I'm going to have 1, 2, 3, 4, 5, 20 bits, right? So, and then the first card will be the biggest one. The second card is the second biggest one. So this basically does all our tiebreaker for us. Because this can be up to a little over 1 million, I decided to make our major rankings just 100 millions. So I just made it easier. So 1 pair is now 100 million, 200 million for 2 pair, all the way up to 600 million for 5 of a kind. And so now your total score is going to be your major ranking, which will be, say, 400 million or whatever, plus your tiebreaker, which is up to 1 million-ish. And that way, every hand gets a unique value that is perfectly ranks them between each other. So we can use that as our sort key. So the next question is doing the logic for all of the major hands. So the way I just started to do this to begin with was using sets. I probably should have done maps to begin with. I thought about that halfway through. We'll talk about that in the second part. But basically, for some of these majors, this is pretty easy. So 5 of a kind, we're going to take our hand, we're going to split it to a character array, and then we're going to do that to a set. So with the set, everything can only go in at most once. So if I have like 5 kings, I push a king in, I push a king in, it overwrites the first one, I push a king in, it overwrites, so on. I push 5 kings in, I still only have 1 element in my set, king, right? I can't have duplicates. So if the size is equal to 1, that means all of our cards were the same. We have 5 of a kind, 600 million points. Great, good job. Okay. So 4 of a kind is similar, but the logic's slightly different. So, because you can think about like a 4 of a kind, you have like 4 of one value and 1 of another value, right? So you have 2 different things. But with a full house, you have 3 of one value and 2 of another value. And those hands are different, but they both have 2 unique values. So for 4 of a kind, basically I'm checking for 2 unique values, the same way we did with 5 of a kind. But now I also need to check if any of them have 4 copies. So if we have 4 copies, one of them must either be your first number or your second number. So if your first number is in there 4 times, we're good. If your second number is in there 4 times, we're good. We don't have to worry about any further than that because your third, fourth, and fifth numbers cannot make it a 4 of a kind. There's not enough cards. So then after that, full house is pretty easy. It's basically if we have 2 unique values and we're not a 4 of a kind, it's a full house. Great. So 3 of a kind is basically the exact same thing. So if our set size is 3 and our first card or our second card or our third card has 3 copies in the hand, then that's a 3 of a kind. Again, we don't have to worry about the 4th and 5th because they would have been in one of these 3 cases. If we have a unique set of 3, but we don't have a 3 of a kind, then we have to have 2 pairs. So we'll have like 2 of these, 1 of something else. So we'll still have 3 unique values, and it wasn't one of these, so we know it has to be a 2 pair. And then 1 pair is pretty easy. It's if you have 4 distinct values, then 2 of them must match, so you have a pair. And lastly, if you have nothing, then we just return your tiebreaker score only, and we don't add anything else to it. Once we have all of that scoring done, putting it all together is pretty simple. So I'm going to take our input, I'm going to map it to a list of strings, or a list of strings, because I'm going to split it on spaces. So now I'll have a list of this string and this string as an array, and then a list of this string and this string as an array, down the whole list. And then I can sort them by our scoring function that we just did. So whatever our hand is, I'm going to pass that into our scoring function and use that as our sort key. And then once that's all done, I'm going to use the map index function, which is basically a standard map, but it also gives you this index value. And so this is going to be 0, 1, 2, 3, all the way up to your max. And the hand is basically your standard iterator. And so for index and hand, I'm going to say our hand.1, which is again our bid function, times the index that we were starting with plus 1. So again, we want our 0th index, our worst hand, to be worth 1 point, because Kotlin is always 0 indexed and AOC is always 1 indexed. Anyway, we'll do all that. We'll sum them up, return them, easy enough. For step 2, the part that gets trickier is now we're including jacks or jokers. But to make it even, they're also now the worst individual cards, so they're worth less than a 2 on the tiebreaker portion. So all that's pretty self-explanatory. So to do that, I just copied my ordinals over to the exact same thing, but I changed the jack to be worth 0 points. I don't know why it's after putting that. But jack is worth 0 points, and everything else is the same. And then we just need to get a solver for that. And the solver is going to be pretty similar up here, except our tiebreaker is now using the second ordinals. And then, as I mentioned before, what I wanted to do the first time was to probably just do a mapping. It just makes some of the math a little bit easier because you don't have to like do every edge case every time. And so to do the map, I'm going to use the associate with operator, and the associate with basically takes whatever the value that you're mapping over, in this case the keys, and I'm going to turn that into a pair, and the second part of the pair is going to be our associated value. So it's going to be our how many. We're going to go through the hand, and to a character array, and we're going to count how many of each pip they are that matches that key. So basically, our ordinals keys, again, that's going to be ace, king, queen. We're going to find how many of those aces, or how many of the cards in your hand match that, and put it in there. So we'll have a key of ace to 1 if there's one ace, king to 0, queen to 0, jack to 3, or whatever. And we're turning that into a map. So this is just a quick way to count how many copies of everything we have. And then I'm going to find out how many wilds we have by just pulling out the count for jacks. And then I'm going to set the jacks to 0 because otherwise you keep running into the problem where your jacks are could be like in multiple locations. Like, you know, if you have 3 jacks, you shouldn't have a 3 of a kind because you'll have at least a 4 of a kind, right? So when we get down to it, we basically assume that a jack will never actually be used as an individual. It's always going to be part of something else in here. So now we can basically do the same logic, but we're going to use the map instead of using a character array and set. So I'm going to take my counts. I'm going to filter any of them that have a value where the value plus the wild cards is 5. So if we have any cards that with wild cards, we have 5 copies of 5 of a kind. And the same thing with 4 of a kind. And then full house is slightly different because we need 3 and 2 naturally, or we need a pair and a wild. So if we had 2 wilds, like let's say that we have a pair of one and a singleton of the other, so we only have 1 pair, then and 2 wilds, well, 4 of a kind would still be better. So we're not ever going to have more than 1 wild at this point, or we would have kicked out at that point. So 3 of a kind is basically the same thing if the number plus wilds is greater than or equal to 3, and then 2 pair is if we have exactly 2 that have 2, or we have exactly 1 that has 2 and a wild. And then 1 pair is we either have a natural pair or we have any wild. If we have any wild, we have at least a pair, right? And if we don't have any of those things, again, return the standard score. So that's just the scoring difference for those parts, and then the actual math looks basically the same. We're just going to, you know, parse it, split it, score it, sum it. Anyway, that's all it for today. If you got any questions or comments or anything, you know, of course, drop it down below. I'll have the updated code in the GitHub as usual, and other than that, I will see you tomorrow.